All right, so our last type of sampling method that we're going to talk about, well, not last because there are more, but the last of the big four is a systematic random sample. A systematic random sample is random sampling but with a system involved. So what we would do is, if I were in class again, I would roll a die to figure out where my starting point was. So say I rolled and I got a 3. And then from then on, I would count out and choose every 5th student. So I'd go 1, 2, 3, 4, 5. You're in my sample. 1, 2, 3, 4, 5. You're in my sample. So it should have randomness, but it's not as big a pain in the butt as writing everyone's names down. So again, we're sort of just making the process a little bit easier on us than having to get out a random number generator or put names in a hat. The big thing here for a test, these are super easy to spot. You're going to have something saying every kth, every 5th, every 7th, every 24th, some number telling you when those regular intervals are. So spotting this on a test, pretty straightforward. If you are making up a systematic random sample, do try to make sure that whatever number you choose would result in the sample size that you want while covering everything. Cat's meowing at me. So, for example, if there were 400 people and you wanted a sample of, say, 50, you would need to choose every 8th person. So keep that in mind when you're creating a systematic sample. The last of the good sampling methods, not something I usually test on, is a multi-stage random sample. Usually what the problem is that our population is something so cumbersome. We can't just get a list of every person in the US and start counting off every, whatever number or randomly selecting them. So we'll do some sort of combination of these things instead. So you might end up doing a little bit of stratified, say, let's make sure that we get a certain number of people from each state, proportional to the number of people who live there. And then within each state, we're gonna have to take a sample. So there's multiple layers. Or you might take a region and then take a sample within that and then go and do your systematic sampling within those different states or whatever it might be. So combining those is a multi-stage random sample. There are some bad sampling methods that are available. Voluntary response sampling. So if I asked everybody, please respond to this survey, and I only get 10 of the 50 students responding, we saw this with the political scientist example. We're going to run into trouble with, those people who respond being the ones who care the most or just the most involved, and therefore will be different than the people who didn't respond. The other would be convenience sampling. If I'm trying to make a conclusion about all the stat students here at Mesa, and I just use my students because you guys are the easiest for me to get a hold of, you are not the same as the other students in the other classes, right? There may be some reason that you're different. My classes tend to fill up early sometimes, so that might be an issue. Also, we're missing out on anybody taking night classes. So both of these methods will have a lot of undercoverage, a lot of different biases seeping into them. Okay, so here's another chance to test whether or not you've got it. I want you guys to pause again the video. I'll give you a second in a moment. Your options: SRS, stratified, cluster, and systematic. So go through each of these and decide which one is which. All right, so hopefully you did this. You paused. So if we pick every 20th name, again, this is actually going to be perfect because 2,000 divided by that 20 would give me 100 people, which is what we're looking for here. But that 20th tells us immediately this is the systematic. This is our system, right? That irregular interval is our system for our random sample. Cat! Sorry, the cat was doing something bad. Separating students by class and then taking a sample from each of those groups. Here we have that nice from each of the groups, and we're sampling. These samples are students, right? So this is our stratified. Again, this is going to be one of the biggest problems on the test, is telling stratified and cluster apart. Using a random number table, 100 names are chosen at random. This is incredibly boring. It's an SRS. And then the last one, we're separating students by homeroom assigned. So again, we have our grouping. But now we're picking a random sample of 4 homerooms. We're sampling the groups. So we are talking about a cluster sample. So those are the big four. And then we can move on. Another question I like to ask on the test is something about sampling bias. How are these things biased? There are some definitions here in terms of different sampling biases. The way I test, usually either something about the definitions or just giving you an example and saying, how is this biased? Write out something. Don't necessarily care then as much about using the terminology as much as just your good critical thinking skills, which you probably have seen, sort of like the airline Thanksgiving question from the homework. So sampling bias, you can see here, tendency to favor selecting people or elements that have a particular characteristic. Usually a bad plan is the problem. So the very best strategy is to choose people at random. That was one of the things, especially in my second class, you guys said, what do we need from a good sample? We need it to be random, definitely. If we have that randomness, we should have a sample that looks like our population on average. That doesn't mean we're guaranteed to get a sample that looks like our population. The more people you take into the sample, the more information you have, the better your estimation will be. So bigger and more random are better, but this is the big note. This is what we saw in that Literary Digest example from the last JITT. If your sampling method's flawed, taking more people is not going to fix anything. It's just going to make you feel more confident in what you have found, which is still just as insanely incorrect. So our types of sampling bias, there are three. They are pretty much what they sound like. Under coverage means we didn't fully cover everybody. We left someone out. This would be the example of people without a permanent mailing address in our census. Non-response, this is including people, choosing them in the sample design, and then they do not participate. This is what we saw actually in the political scientist example, right? Her sample was that she wanted was 250 people, or students from her college, but only 104 participated. So usually this is one of the easiest to spot because I have to give you some sort of numbers saying, okay, people didn't respond. So it's pretty straightforward. The last is response bias. And this is some reason we might get inaccurate information, usually based on the behavior of the interviewer or the respondent. So this will influence your outcome. I think we see an example of this on the next page. But in case we don't, this would be like me verbally asking students about drug use. No one is going to, hopefully, not many of you people would answer that truthfully if they actually did. So these are our big three types of sampling bias. But again, this question could just be a more general, what are some things that you could see going wrong? Because that's more just critical thinking, and I like that question. So we have an example of response bias here, basically showing you how you write a question, which is why there's so much time and money spent on survey design. How you write a question greatly influences how people respond. So asking if a budget surplus should be used on a tax cut or for government programs is going to elicit a very different response rate than asking if it's used for a tax cut or spent on programs for education, the environment, healthcare, crime fighting, and defense. There's even studies showing that the order in which you ask questions matters. You could swap an order of two questions and you could change your response rate from like 20% to 80% saying yes. So there's a lot of time and money spent so that we don't hopefully prime people and we're getting the right information that we want. So again, we're going to do this identifying the largest source of bias game. Our options, just to re-put them in here, under coverage, non-response, and response. So take a moment, pause your video, read through these, and decide. Okay, so first one, now that you're back and have decided, again, we mailed a questionnaire and we received responses to 23% of them. We've been given a number or percent saying people didn't respond. Lovely. Non-response. Now, I have a lot of students who get distracted by the fact that it says, but the people said they don't think it intrudes on their work days. And obviously, if they were the people who thought it was true. So non-response, again, you're going to get a biased sample. Your answers and your outcomes are going to be different because of the fact that people didn't respond. Those who thought it intruded didn't. So this is not response. It is not response. I did have an example, Trat, for the next one. Verbally administering surveys about drug use, you're probably going to get some students not responding. So anything that is sensitive at all, you should be asking in an anonymous format where people can either answer like online or in a survey that you're putting into a box or something where you can't figure out who it belongs to. Our polling organization, they mail questionnaires to 1,000 households and 15 questionnaires are returned. So again, we're given some sort of number telling us that we have non-response. I realize, again, mailing a questionnaire in English and asking if English is the primary language is silly, but that's not the biggest issue. The biggest issue is, holy crap, we have less than 2% of people responding to said survey. All right, last one here. State group, blah, blah, blah. Our issue with this one is undercoverage. Undercoverage tends to be the hardest one to spot because you need to do what we did in that political scientist example in order to make sure you've got it. What is the population they're interested in? Interested in whether voters would support lowering the drinking age. So our population is voters. Who do they go talk to? They randomly select 25 students to see whether or not they approve of the drinking age. So again, the biggest problem here is the disconnect between voters and students. We've left out everybody who's not a student. That's a huge amount of undercoverage. It doesn't matter that students are going to be the ones that are more likely to want to lower the drinking age. That is going to be a problem because of undercoverage and the bias in the survey. All right. Last piece here. Answer the following. I'm going to give you guys a moment to read through this. These are very good questions that would be like on a test. So take a moment, pause your video, try them, please. Okay, now that you're back. The first question, I'm going to tell you the most common mistake. I love this question. In fact, it's one of those ones that I usually do in class, just so I can see how everybody has different answers. But your answer here should have been cluster sample. I know why people choose the other ones. Students sometimes choose simple random because they see randomly selected. There's random selection in every sampling method. The only one that's a little bit different maybe is the systematic, but it's always going to say something about randomly selected. So don't jump into simple random because of that. A lot of students want this to be a convenient sample because it is convenient that they just went to one park and asked the bird watchers there. The issue here, though, again, comes back to this randomly selected. If it was truly a convenient sample, they just would have gone to the nearest park and asked people. Since they chose a randomly selected park and asked people, this is a cluster sample. We went to one place and we took everybody, right? We sampled basically the park, the group, and then we used the entire population there. So there we go. 6, what could go wrong with this? I like this question because it kind of shows how my wrong answers sometimes look. A, this bird watcher selected from the national park may create an unbiased sample. Our problem there is the un. 2 letters make this incorrect. The chosen national park may not accurately represent all national parks. This is our correct statement, right? I don't know where bluebirds are found, but if you're in a part of the country where there aren't bluebirds, this would be a really silly survey. The national park is selected at random, therefore the data is relatively unreliable. Again, we have a problem here. Random is good, right? So we have an issue. This part is correct. The back half is incorrect. So I could see students choosing it. And the sample size may be too large, which makes reading the data difficult. No, we're in the day and age of big data. And 23 is not big data. So, and even if it were a large number, it would not be a problem. So I'm going to end this video and do one last one, and we'll finally be done with part 1.